When starting a new simulation, you're faced with the dreaded blank piece of paper problem. You have a totally empty simulation and you want to start adding some agents, get them in the mix, and create an interesting simulation. How do you go about doing that? We call the process of creating agents at the beginning of a simulation initializing, and there are two main ways of doing that. The first is by adding agent data to init.json. You can define agents as blobs of JSON in the init.json array, and any object that is present in the array in the first time step will be initialized at the beginning of the simulation. So let's create a few agents. We'll call one Bob, which is my default name for agents. We'll give him a position of 0, 0. And we're not going to use it yet, but we're going to add a behavior array. So if we reset the simulation, boom, Bob appears. Whenever you reset the simulation, any agents that are defined in init.json will appear in the 3D viewer if they have a position. Let's add another agent. Let's call this agent Alice. And give them a position of 0, 1. And just to differentiate the two, a color of red. Now you've got two agents in your simulation. The other way of initializing agents is through behaviors. If we go into a behavior like initialize.js, we can add custom logic, which you see I've already done here, to create agents on the fly. The agent defined here will be added to the simulation by sending a message to hash to create an agent. If you send a message to hash, it's sending a message to the engine that's being run in the current simulation. And if it's of type create agent, any data that is defined in the message payload will be used to create an agent. And so we've got one here that has position of 0, 5, an agent name of Sally, a random property and value, and an age that's going to be randomly assigned. This is one of the main reasons why you might end up using a behavior to define an agent instead of writing it out in init.json. Init.json is compliant JSON. That means that you can't set any JavaScript codes or dynamic values in init. You have to do that in a behavior and then send it to hash to create the agent. So if you want, as you probably will in many of your simulations, to have dynamic values, or if you want to create a lot of agents, for instance, adding a for loop here and sending this 100 times to hash, you're going to want to do that in a behavior. This is a pretty common pattern, these creator behaviors. If you search in the hash index for published creator behaviors, for instance, if we start searching for the keyword create, a number of them are going to come up with their own logic for taking some predefined template and then initializing an agent that reflects that. And by mixing and matching some of those behaviors or your own custom behaviors, you can create really complex simulations with many different agents. Let's give this a whirl by adding initialize.js to Bob. Now we expect two things to happen. On time step 1, Bob is sending two messages to the hash engine. The first is to create a new agent, that's Sally, and then the second is a remove agent message. The remove agent message tells the agent to remove an agent, appropriately enough, and if there's no data supplied, hash will remove the agent that sent the message. So as you can probably guess, the two things that are going to happen are Bob is going to disappear and we have a new agent, Sally. I actually want to rerun that and give Sally a different color so it's a little bit more clear that Bob isn't moving, we're creating a new agent. So Sally is going to be blue. And now let's reset and run our simulation. And there you go. We've got two agents now, Sally and Alice. And Sally has an age of 37.7 because it's been dynamically assigned. If we rerun this, I bet she will have a different age. As you can see, by combining many of these different behaviors together and trying different patterns, you can create simulations with any number of complex heterogeneous agents.